All right, prove that real z is less than or equal to mod z. So let's have a look at what mod z is. So if we let z equal x plus iy, what have we got? We've got mod z, we already know, is the square root of x squared plus y squared, right? Because that's just the length of that vector or the length of that complex number. Now we know if we wanted to head to just real z, remember real z is that's just x. So that's just that part there, just the x. So we just want to get rid of some y's. Well, why don't we say, and we can bring in an inequality, which is what we want. So that square root of x squared plus y squared, that has to be bigger or equal to just the square root of x squared if we forget about the y squared, right? Y squared is positive, so that is going to be bigger with the y squared than without the y squared. And we know that the square root of x squared, using our properties, that's the same as mod z. Now mod z, if you think about it, mod x, so now we've just got x, which is what we want. Mod x is just taking the length, so it's the positive. So it's going to be either equal to or greater than. So if x is negative, mod x is going to be greater than x. But if x is positive, mod x will be equal to x. Okay, and so x is equal to a real z. So therefore now you've got that our mod z is greater or equal to our real z, which if I write it backwards is what we wanted. So real z is less than or equal to mod z. Now it does say under what circumstances are they actually equal. Well, if we got rid of y, so if we didn't have any y's, then because mod z of course contains y's, so if we got rid of y, so if we said when y equals 0, that's getting rid of, and then we'd just have the x. But remember, if we've got modulus, that's taking the positive. So if it was a negative x, it wouldn't be the same because real z would be a negative, whereas mod z would be positive. So I guess, yeah, when y equals 0 and when our x is positive, then they would be equal. All right, so part B, we want to prove, let's get rid of that. So I'll probably need it, let's see. So we want to prove the triangular inequality, but we want to prove it by beginning with this peculiar thing here. So z plus w, or mod squared is z plus w times the conjugate of z plus w. All right, so let's just pretend we've written that out and we'll go equal here. So we've got, what do we have? We've got z plus w, so let's just multiply and expand out. So I'm going to have z, and we can do that because of the properties. Z bar, what else are we going to have? Z w bar, we're also going to have z bar w, we're also going to have, sorry, we've done that one, so we're also going to have w bar, okay? Now again, we know the properties, so z bar is the same as mod z squared, and w bar is the same as w squared. And then if you think about z, so you can do it, so try yourself. If you want, let z, for example, be a plus ib, so z bar would be a minus ib. Let's make wc plus id, w bar would then be c minus id. So if I multiplied z by e, there we go, the conjugate of w, I'm going to have ac minus iad, that's multiplying by the a's, and then the ibc, should have done it properly. And then negative times positive is a negative, but I times I is a negative. So that's going to be positive BD. So if I multiply, I might as well just do it. Okay, so if I multiply those, I get that. If I multiply WZ bar, I'll do it so I can see it a bit more easily. Z bar is A minus IB. All right, so I'm going to get AC. I'm going to get AD with the I. I'm going to get minus CB with the I. And I'm also going to get minus I squared, which is positive, and BD. What happened there? So positive BD. All right, so you can see that colour code for you. So if we add those two things together, we're getting 2 lots of AC. These ones are cancelling. These ones are cancelling. And we're getting 2 lots of BD as well. So we are getting the real parts and the imaginary parts are going. So another way to say that is, and we're getting 2 lots of those real parts. So A times C and B times D. So we're really getting 2 lots of, another way to write it, and you might want to kind of memorize it, is 2 lots of the real part of our Z conjugate W is the same. Okay, so if we take just our ZW conjugate or our WZ conjugate, doesn't matter which one, we're just taking 2 lots of the real part. It equals the same thing. So you see if you can remember that. But you can always just work it out as well. So, delete that. All right. So what are we up to? Remember what we're trying to prove is over there, is that triangular inequality. So how do we get there? Okay, so it is an inequality. So if we think about it, the thing that we've already got, so this line, is going to be either equal to or smaller than, if I keep that, so far it's the same, keep that, so far it's the same, but what if I just do 2 lots of Z omega bar modulus of that, so the length of that. Okay, so if I take 2 lots of the real part of Z conjugate W, it's going to be less than or equal to 2 lots of the modulus of Z conjugate W. All right, so again, you can have a look and make sure you agree, prove it to yourself. And so now what I've got above is, if I use my properties, I can break this up. And then that is equal to, again, if I use my properties, modulus is just the length. So remember, the length of the conjugate is the same as the length of the actual. So let's say it was up here, the conjugate would be down here. Their lengths are the same. So instead of W bar or conjugate of W, I'll just say W. Sorry, I'm interdispersing a W and an omega, same. Okay. And the reason I do that, of course, is because if you think of A squared, A plus B all squared, that's what this is giving us. It's giving us mod Z plus mod W all squared. Because I'm looking at getting this and looking at this. So what have I got? So at the moment, if I put this back in, you might be able to see it. I've got this, Z plus W, modulus of it all squared, is less than or equal to, because we did put that here, we do have our less than or equal to. So it's less than or equal to our square of mod Z plus mod W. Okay, so I could say, so therefore, this is what we've got. Oops. There we go. Z plus W squared is less than or equal to mod Z plus mod W all squared. And since all those properties, all those quantities that we're looking at are positive or 0, we can square root both sides and the inequality will hold, right? Because they're both positive. Everything's positive on both sides. So we can say instead that the modulus, so square rooting both sides, is still less than, and square rooting this side, we get that, which is our triangular inequality. So also, if you think about what you're heading towards and what you've got, we could kind of think, oh, let's square those both sides and have a look at what that is. And then I would kind of work backwards and get to there and go, okay, so I need to actually expand that out and have a look at that. And then in the other direction, I've got to, and that equals that. And the other direction I've got to here. So we can compare those two things.